Hello, students. So, Chapter 13, which is this week's work that we're going to be doing in our math class, is a lot of information. We're going to be going over IV calculations for several different types of medications. We're going to do milliliters per hour, drops per minute, calculate the time remaining on bags of fluid when given information. So I'm going to have several different YouTube videos this week. I'm trying to break each of these down into kind of workable bits. So the first part, or the first YouTube video for this week, I'm going to be solving for milliliters per hour. So this is the first part of our chapter in chapter 13 in your book. So again, I'm going to work a little bit of these, and then I'm going to provide you the answers for the rest of those and let you kind of figure them out before you turn in your homework, and then obviously before you do your test for this week. So when I'm doing this information, or when I'm doing these types of problems, again, I always work dimensional analysis problems exactly the same. I always write my information down over on the left side of the column, so that way I know what information I need to use, and then ultimately what I'm solving for, so I know how to set up my dimensional analysis problems. So in the first problem here, it says cefepime 1 gram diluted into 50 milliliters of normal saline to infuse over 30 minutes is what we're ultimately looking for. I'm going to have to get a different pen because all the ones I've used thus far don't have very much ink. So I'm going to write over here, again, to the left side here. So I have 1 gram to be diluted into 50 milliliters, and that needs to be infused over 30 minutes. So again, this is a sentence, and this is the information that is in that sentence, or in the problem. And again, here I'm solving for how many milliliters per hour. So when I'm plugging in my information, I'm going to use this information. Now you will find that this week we got to learn some things as far as what not to use when we're dealing with our problems. So with the same type of process that we've used thus far, solving for dimensional analysis, since we're solving for milliliters per hour, I'm going to start with milliliters on top, and then ultimately over here we're going to end up with hours. So of my information, what has milliliters in it? So you'll see here we have 50 milliliters. Now you'll notice that we have the 1 gram and then also 30 minutes here. This is what I was talking about when we have to figure out what not to use in a problem. But since this particular volume, which is 50 milliliters, and we want to know time, that's what we want to put with our milliliters, is the time that it is being infused over. So in this case, we're going to be putting over 30 minutes. So let me kind of explain this a little bit more. So with this information, you're thinking, okay, well, why don't we use the 1 gram? What it's basically telling us in our problem is that this 1 gram is in this 50 milliliters of volume. So that's why we are not going to use that to use or plug into our dimensional analysis problem. So of our 50 milliliters over 30 minutes, again, with dimensional analysis, if this is minutes, this has to be minutes. And we want to go to hours. So then you go to your known conversions, and we know that there is 60 minutes in 1 hour, and then we're going to be left with milliliters per hour because our minutes have just canceled out. So we're going to do 50 times 60, which gives us 3,000, over 30 times 1, which is going to be 30, which is going to give us 100 milliliters per hour. Is the answer to that one. So, as you kind of go down through these, and again, I've posted these, this assignment online for you, so you can work through these, and again, I'll give you the answers to those, but I kind of just want to help you at least solve one of the questions based on the information that we're given, and to make sure that you know how to work all of those. So the next one that I'm going to do on this chapter, again, well, chapter 13, but still solving for milliliters per hour. So I'm going to go ahead and put that down here, because that's what tells us at the top of the page. So here we have naphthalene, 1 gram, diluted in 140 milliliters to infuse over 2 hours. So with this one, I'm going to put my information. 1 gram is diluted into 140 milliliters, and that is to go in over 2 hours. So there's our information sentence. So again, solving for milliliters per hour, I'm going to start out with milliliters here, and of our information we have 140 milliliters, and the time, again, since we're dealing with time, is over 2 hours. And since we're solving for hours, and we have hours here, that's all we have to do. We don't have to do any more with that dimensional analysis. So we're going to do 140 divided by 2, and that's going to give us 70 milliliters per hour. Alright, now let's move down a little bit. Again, all of these are going to have the same information. 32 milligrams diluted in 50 milliliters over 15 minutes. 120 milligrams diluted in 250 milliliters over 4 hours. So let's move down here to this one, which is just, again, written just a little bit differently. With this one, our information is we have 1,250 milliliters, and we want to infuse that over 8 hours. And again, we're solving for milliliters per hour. So here, again, starting out with milliliters on top, we're going to put 1,250 divided by 8 hours, and that's going to give us 156.25, and it tells us on the front here that we're solving for milliliters per hour, and we want to round to the nearest whole number. So with that being said, we need to round this one. So 156.25, rounding that to the whole number, is going to be 156 milliliters per hour. And the next one, 250 milliliters over 2 hours, 2 liters over 18 hours. So let's do this one. Whoops. Because it's just written a little bit differently. So my information is we want 2 liters to infuse over 18 hours. And again, we're solving for milliliters per hour. So with our dimensional analysis, we want to solve for milliliters. Well, we go back up to our information here, and it is in liters. So we need to convert and go from milliliters to liters, and again, go back to your known variables, and of that, we know that there are 1,000 milliliters in 1 liter. And now, again, continuing on with your dimensional analysis, since this is liters, this has to be liters. So now, that's when we can plug in our 2 liters, then over 18 hours. And ultimately, our liters are going to be canceled out, leaving us with 2,000 over 18, and that gives us 1 111.1 repeating, and again we're rounding to the nearest whole number here, so this would be 111 milliliters per hour, because again we're left with milliliters per hour. Okay, so this next one here is infusing 500 milliliters over 90 minutes. So I'm going to write this over here, 500 milliliters to infuse over 90 minutes. And again, we're solving for milliliters per hour. So I'm going to start my dimensional analysis with milliliters. So here we have our information sentence. So 500 milliliters over 90 minutes is what we're given. And we know that that's not what we want. So with dimensional analysis, we have minutes here, and we're going to hours. So what is our known conversion going from minutes to hours? Is there are 60 minutes in 1 hour, leaving us with being able to cross out our minutes. So we have 500 times 60, which gives us 30,000 divided by 90, which gives us 333.3 repeating, and again, rounding this to the whole number is going to give us 333 milliliters per hour for our answer. Okay, so let's do this next one. For our information, we are wanting to infuse hydromorphone 1.5 milligrams diluted into 5 milliliters to infuse over 5 minutes. And for a syringe pump, again, solving for milliliters per hour. So I'm going to write my information here. 1.5 milligrams being diluted into 5 milliliters. And we want that to go over 5 minutes. So, with our dimensional analysis, solving for milliliters again, ultimately for hours down the way, but of our information sentence here, we're going to put 5 milliliters, because that's what we're given. And again, since we're dealing with time, we want the time aspect of this information, because again, this 1.5 milligrams is in the 5 milliliters, so we don't need to use that into our problem. So here I'm going to put 5 milliliters over 5 minutes, and then since that's not what we need to end up with, we need to put minutes here in order for our dimensional analysis to cancel out, leading us from minutes to hours. So again, using a known variable would be 60 minutes over 1 hour. Now doing the math, 5 times 60 gives us 300. Then over 5, because 5 times 1, and that is going to give us 60 milliliters per hour.